All right, this is Unit 3, Lesson 5. Our learning objectives today are I can solve two-step problems using a variety of approaches, including equations, drawings, and mental math. Remember, mental math is math that you can do in your head. All right, raise your hand for page 135. Sometimes you will need to work through more than one step to solve a problem. The steps can be shown in one or more equations. Let's look at number 1. In the morning, 19 students were working on a science project. In the afternoon, 3 students left and 7 more students came to work on the project. How many students were working on the project at the end of the day? So what is this problem about? This problem is about students working together on a science project. Okay. They are working on a science project. Okay. What do you need to find out? How many students were there at the end of the day? Okay. All right, so to solve this, students, I'm going to have 19 students. And I know that 3 students left. Key word here is that they left. Okay, that means subtract. So I'm 3 students left. 9 minus 3 is 6. So now there are 16. 7 more students came to work on the project. They're coming, 7 more. That means I'm adding 7. 6 plus 7 is 13. 1 plus 1 is 2. Okay? How many students are working at the end of the day? This is my final number. So that means there are 23 students working. Number 2 says solve the problem again by finishing Tommy and Lucy's methods. Then discuss what is alike and what is different about each method. Okay. Tommy method says write an equation for each step. Find the total number of students who worked on the project. So he did 19 plus 7 equals 26. And then he took subtract the number of students who left in the afternoon. So he did 26 minus 3 and got 23. So he added the 7 first from the 19 and then took the 3 away. Lucy said let n equal the number of students working on the project at the end of the day. Okay, so she put n at the end of the day. Students who left in the afternoon, okay, I know 3 students left, and then students who arrived is 7, and then she did it in order, so she did 19 minus 3, which is 16, 16 plus 7, which is 23, very similar to how we did it up here. All right, let's look at number 3. Number 3 says, a team is scheduled to play 12 games. Of those games, 7 will be played at home. The other games are away. How many fewer away games than home games will be played? So first I need to determine how many games are away, okay? Because I know how many are home. 7 will be at home. There are a total of 12. 7 are at home. I need to determine how many are away. So 7 plus what equals 12? I know 7 plus 5 equals 12. So there are 5 away games. Now it is not asking me how many away games. It says how many fewer away games than home games will be played. So if I'm comparing 7 versus 5, I know that 7 minus 5 equals 2 fewer away games. Again, this is really important that you read how many fewer away games and that you didn't just stop at away games. Okay. All right, raise your hand. You need to get a star for this page. Then we are moving on. All right, let's look at one more problem before we move to the next sheet. Jack has 4 baseball, 9 basketball, 7 hockey, and 15 soccer posters. How many more soccer posters than baseball and hockey posters does he have? Okay, so first I need to determine how many soccer posters. Okay, soccer posters, he has 15. Then I'm going to compare baseball and hockey. We're going to combine baseball and hockey because it says baseball and hockey together. So baseball and hockey equals, here's baseball, here's hockey, 4 plus 7, which equals 11. Okay. Then it wants to know how many more soccer than baseball and hockey posters does he have. Okay, so this was my first step. Now I have to compare 15 and 11. I know that 15 minus 11 equals 4 more soccer posters. What is some of the extra information that we had? Do we need basketball for anything? No. That was just extra information that we did not need. Okay. The missing information we had to figure out was how many together baseball and hockey. We had to add that together first to get 11 and then compare. All right, let's look at page 136. Remember that these are all two-step problems. Okay. You can use any of our methods that we've learned the last couple of days to solve. A garden contains 54 vegetable plants. Altogether, the garden has 63 fruit and vegetable plants. So I know fruit plus vegetable equals 63. How many fewer fruit plants than vegetable plants are there? Okay, so I know that there are 54 vegetable plants, so I can say F plus 54 equals 63. To solve that, I need to do 63 minus 54. And actually, that's easier if we write it this way. Remember, I can't do 3 minus 4, so I need to borrow. 13 minus 4 is 9. So I know there are 9 fruit plants. Okay, there's 9 fruit. But the question is not how many fruit plants there are. The question is how many fewer fruit plants than vegetable plants are there. So I'm comparing 54 and 9. So I subtract 54 minus 9. Again, I need to borrow. 14 minus 9 is 5. And 4 minus 0 is 4. So there are 45 fewer fruit plants. Okay. All right, go ahead and work on 5, 6, 7, and 8 on your own. When you are finished, raise your hand. You need a star. And then we are moving on to homework. Homework, front side, you need to do all. Back side, we are going to do odds only. Okay. Remember for these top problems, I'm going to do number 1 here. If you're trying to find this one, you can use the inverse operation. Remember inverse operations? The inverse operation of division equals multiplying, and the inverse of adding is subtracting. So if I have a division problem here that I'm trying to solve, and I use the inverse operation, I know 7 times 9 equals 63. So 63 divided by 9 must be 7. Use that to also help you here. 21 divided by what equals 3? Or 3 times what equals 21? Okay. Again, you're doing odds only. Remember here, you need to use PEMDAS. Okay. All right, you can go ahead and get started as soon as you are finished. You can work on IXL. Please look at the board for which lessons you should do on IXL.